Hello, on September the 10th. All right, let's do this. Tomorrow is going to be the interview. The original plan was to learn a little bit more React, so I won't be completely um, a moron during the interview, but I don't think I have time for that. So I'm going to let it pass and then just see what I can do during the interview. I hope all these practice can really help. Wait, hold on, we done this one, right? The yield. Yeah, we done this one. Oh yeah, turn off. Or cancellation. Oof, nice. Okay, anyway, we have to do this one first. N people that are split into some unknown number of groups. Each person is labeled with a unique ID. You are given an integer array, group sizes, where group sizes I is the size of the group that person I is in. For example, if group size 1 is equals 3, then person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group of size. Each person should appear in exactly one group, and every person must be in a group. If there are multiple answers to any of them, it is guaranteed that there will be at least one valid solution. So, in this case, we have n people. 1, 2, 3, 4, 5, 6, 7. Well, actually, 0 to n minus 1. So 0 shall be in with a 3, 1 shall be in a 3, 2 shall be in a 3, 3 shall be in a 3, 4, well, hold on, 0, 1, 2, 3, 4 should be in a 3, 5 should be in a 1, and 6 should be in a 3. I see. How you gonna do this? Well, okay, hold a second. If I have 3, 3, 3, 3, 3, 1, 3, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Yeah. So I can say 0 is a 3, right? So size 3, I can have a size 3, so we put 0 in. And then 1 is size 3, so we put 1 in. 2, put 2 in. And then this comes in. We check 3, it's already 3, so this gets pushed out into the result. And this will return this with a new one. And we push 0, 1, 2, 3, 4 in this, 5 in this, 0, 1, 2, 3, 4. No, 3 in this, 4 in this, my bad. 3 in this, 4 in this, and then 5. 1 doesn't exist, so we do a 1. And 6, push in. Done. Whatever you push out. Oh, that's it. Alright, so now I think the only thing that's challenging is we have to code this in Java. What do you think? I need a hash map with integer and a list of integer. We call it group map. Okay. Then we'll call a list integer. Result equals new list. No. Oh shoot, my bad. Hash list, not hash list, array list. Array list integer. Okay. Ooh, hold a second. What was wrong here? Oh yeah, you cannot declare it this way, dude. Alright, so what we're gonna do is for int I equal to 0, I smaller than group. Now group size is star length I plus plus. Okay. Then we'll get the first one. Then we'll say Well, say list integer group, right, shall equal to group map dot put if absent. Wait, hold on. What's put if absent and return? The previous value associated with a specific key, or no if there is no mapping for the key. You know what? Previous value associated with a specified key, or no if there was no mapping for the key. A no return can also indicate that a map previous associated no with the key if the implementation supports no values. Wait, does this return the value? No, I think it is to put. Right? Put if absent. If it's absent, then we put it. If it's not, then we don't put it. Yeah, so I think a better way will be just, we'll put if absent group sizes I, right? Then we'll do new array list, right? So we put if absent, so we put it in, and then we can say if group map dot get group sizes I dot size is smaller than group sizes I, right? Then I say group then you get it again, right? Dot get group sizes I. Oh, let's do this. Int size s equal to group sizes I. Then all the group sizes will replace with s. So this dot add I. Else, this is an interesting one. If it's already equal to, right, then we need to yeah, so it's already equal to the size. Then we need to do res dot add group map dot get s. Then group map dot set put as new array list. Can we do arrays dot as list I? Well, it is not allowed. I remember it's not allowed. What can we do? What can we do? I don't like this one. I don't like this one. We get this. We shall say if group map dot get or default as we can say array collections dot empty list. Array list. Wait, hold on. How do we do empty list? Just forgot again. Java collection empty. How do we do this? Yeah, it should be. This shall be good, right? Why? What is wrong with this one? Oh, my bad. Dot size is equal to yeah, I don't know what I was thinking. Equal to s, right? Then res will, if it's equal to, then we will get in and we shall delete, right? Group map dot remove key is going to be s, or remove it. Otherwise, then we will add, then we say group map dot get s dot add I. There we go. I think this is a better sequence. And yeah, no, we'll return res. All right, let's give this a shot. Does that make sense? Does not make sense. Interesting. So I can see 0, 1, 2, right? 0, 1, 2 done. And then 0, 1, 2, 3 comes in. I is 3. As get out default is equal to s. Then we'll add the previous one and I remove. Then we'll put a new array list and I will add it. Oh, I forgot to, yeah, I remember what was wrong. How do we iterate? Oh, I forgot. Oh, I think I know. For list integer, not array list. Come on, array list integer g's of group map dot get values. Pretty sure that's the way it could go. Then rest dot add g's. Ooh, it's not right. Change its type to list. Oh, look at that. Taking viewer at all. Oh, I know. Oh no, hold on. We say res dot add all group map dot values. There we go. Oh, that's great IDE, man. Great IDE. Really enjoy it. Yep. One, two, eight, two. Just go through each person and map its required group size to a group map. Once the desired group has reached the predefined size, remove it from the map and start a new one. Yeah, it's very simple, this one actually. Okay. Let's do this. 11. Okay, let's take a look at our Python code about 1 year and 10 months ago. I do the for dict, the group size. If group G and the len is a smaller, we add it. Otherwise, this one dot append. Oh, it's a default dict. Yeah, I'm gonna lose all the ability to do these things. And it looks very straightforward. I use default dict. Oh, you just add a new one. You don't even remove it. Holy crap. And then you use chain. I think I trial and error for that thing. Let's see. We do answer. A map. You contain key. You put new. Group add. Then remove. Oh, in that case, you do it. You do it inside, right? You do it inside. It's different. Yeah, that's why I have to do it outside. Yeah, that's the only difference. Okay, so that's done. Let's move on. Design a cancelable function. Sometimes you have a long-running task and you may wish to cancel it before it completes. To help this goal, write a function cancelable that accepts a generator object and then returns an array of two values, a cancel function and a promise. You may assume the generator function will only yield promise. It is your function's responsibility to pass the values resolved by the promise back to the generator. If the promise rejects, your function should throw an error back to the generator. If the cancel callback is called before the generator is done, your function should throw an error back to the generator. That error should be the string cancelled, not an error object. If the error was caught, the return promise should resolve with the next value that was yielded or returned. Otherwise, the promise should reject with the thrown error. I don't even understand. I'm just reading it. No more code could be executed. When the generator is done, the promise your function returned should resolve the value the generator returned. If, however, the generator throws an error, the return promise should reject with the error. I don't even understand. Okay, this is a generator function, right? So we'll yield a promise. Hold a second. What is this syntax? Constant val equals yield. So you call next. Each next will execute this, so you get a val. Then you call next again. Then we yield a new thing. And at the end we return. Calculation shouldn't be done. So cancel, promise, cancelable, task. Set timeout, cancel. So after 50, we call cancel. And the promise.catch. Cancel was not called, or was called after t. The promise should have resolved to 5. So a cancel function, so it can be cancelled, right? Accepts a generator object and then returns an array of two values, a cancel function and a promise. You may assume the generator function will only yield promises. it is your function's responsibility to pass the values resolved by the promises back to the generator. What does that mean? To pass the value resolved by the promise back to the generator. So you have to pass it back to the generator. Pass the value back to the generator. I don't understand that. What do you mean by pass the something back to the generator? Oh my god. Oh, dear me. And do we do the... I think I have the generator. I probably need to read it again. Pass the values resolved by the promise back to the generator. If the promise rejects, your function should throw that error back to the generator. If the cancel callback is called before the generator is done, so have more thing in the generator, your function should throw an error back to this. How do you throw? Yeah, and that promise should throw an error back to the generator. That error should be the string canceled. If the error was caught, the returned promise should resolve with the next. If the error was caught, the returned promise should resolve with the next value that was yielded or returned. Otherwise, the promise should reject with the thrown error. No more code should be executed. When the generator is done, the promise your function returns should resolve the value the generator returned. If, however, the generator throws an error, the returned promise should reject with the error. So this one I kind of understand. You make it a cancelable. So this cancel will help you cancel it. This promise is what the task should resolve. But this will take 100 milliseconds, but yours is 50, right? Yours is 50. So this cancel gets called first. Now when this cancel gets called, yield a new promise. After t equals the promise order to resolve is 5. The task will yield a promise. So I can call generated on next, right? So when you call generated on next, they give you a value and whether it's done. Okay, and then if you get a value, but you also need to return a cancel. So when cancel, wait a second. Let's see more examples. So this one just returned 42 and cancelled at, so resolved. And finishes. Because of that, the return promise immediately resolves at 42. Canceling and finished, generator does nothing. Okay, this one will. What does this syntax mean? A promise is yielded. So a promise is yielded. This means to get the value of this promise, I guess. Promise is yielded. The function handles this by waiting for it to resolve and then pass the resolved value back to the generator. Pass, what does that mean? Pass resolved, pass the value to generator. What does that mean? Through done next. Gen call was time return output 1, but the variable input 1 doesn't equal input 1. The value actually is the input 2. Second time next call. Huh? Well-known problem. When you obtain the generator, you don't have yields. You can push value to. You are at the beginning of the generator function. You need to trigger the generator and reach the first yield by calling gen.next without any arguments. At this point, you have an yield at your disposal and you can push your value effectively, replacing the expression yield output 1 with the value you passed to next. Then you need another yield or return to provide your custom value to the consumer. Wait, what does that mean? Alright, let's keep reading. Okay. Uh-huh. Yeah. What if foo can be interrupted? JS is single-threaded. The two threads can only communicate with each other through normal async events. Okay, run, stop, run. Pause in the middle, one or many times, and then resume later, allowing other codes to run during these paused periods. If you've ever read anything, Oh, cooperative. Oh yeah. I thought async await is already cooperative. No, I think I'll wait. I don't know. Pause the function from itself, from inside. Nothing can pause the generator from the outside. It pauses itself when it comes across a yield. However, once the generator has a yield pause itself, it cannot resume on its own, and an external control must be used. I think Python is the same. You yield and then you have to call next. A generator function can stop and be restarted as many times as you choose. In fact, when you specify a generator function with an infinite loop that essentially never finishes, wow, that's usually madness, yes, but we can do that. But I also have a two-way message passing into and out of the generator as it progresses. With a normal function, you get parameters at the beginning and a return. With generator, you send messages out with yield, and then you send messages back in. That's what it means by passing back in. Python has the same, right? Yeah, I'm not very good with generator in general. So that's the syntax. Yeah, it's like a pointer. Yeah, it doesn't really matter. Yield expression and not a statement, because when we restart the generator, we will send a value back in, and whatever we send in will be the computed result of that yield expression. That's a very important concept. So when we do this one will yield full on the outside. And then whenever the generator is restarted, whatever value we send in will be the result of that expression, which will then get added to 1, and then we'll, see the two-way, you send the value out, pause itself, and sometime later, the generator will be restarted and you will give back the value. Yes, it's almost like this is making a request. Pause and waiting for a value. Oh my god, yeah, this is just pause. And then this will wait for a parameter to pass into full. So you call this, you get a generator, and it'll get paused. Then you'll call it next. You'll try to get something here, but it doesn't matter, you just go. The first next call will return 1. The first next call will return 1. The second will return 2. Give back 1 from the yield 1, but that's not the only thing we get back. Yeah, we ought to have this. The final result of a generated function was that we complete a function, but there was no result given. Can I use a return? No one, so yeah. Generated function. Does that value get sent out? Yes and no. May not be a good idea to rely on the return value from generator, because when iterating generator function with a for off loops, the final return value would be thrown away. What? So only the things yielded will be kept, but the things returned will be thrown away. Damn. Okay, yeah, these are the examples I want. So I yield this, so I pass 5, so I got 6 out. That is the first yield. And then, so the first yield, I get yield, but I don't get anything back. It has to be the second one. So I put 12 in. So this will be 12. So y shall be 24. And then we call the next. Oh, hold a second. So every time you call next, you pass a value in, but it doesn't pass to the current one. It passes to the previous one. Right? It doesn't make sense. So you say you yield something, and I call next. I grab you. Right? I grab the current value. And then I say I'll send something in. But since this one's already executed, so when I send something in, I cannot send in this, right? I can only send into the previous one. That's why when we call this, nothing gets sent in at the moment. This is basically sending to the previous yield, but we don't have any previous yield, so that's fine. So we get 6 out. Now we are at this point. So we will... No, we're not at this point yet. Let's do this again. We call next. We get this value, right? And then we pause. Function pause at yield, right? We can just pause. And then we call a next again. So this is a 12. I will push 12 into this one. Compute this. So I push this in, and then I call next, right? And then I call next. So this next is try to yield this, but I push 12 in first. So I get a y, which is 24. Now we got 8. We got an 8 out, right? Then we pause right here. Next one. I call next 13, so I could push 13 in, which means z becomes 13. So we have 13 plus 8 is 21, plus 5 would be... No, it's 24. 13 plus 24. 13 plus 24 is 37. Plus 5, 42. Ah. There's no yield expression to receive what we pass in. Nothing bad will happen. It would just be a tossed away value. It's just the way it's designed. Ignore the unused value in this case. At the time of writing, nightlies of both Chrome are fine, but other browsers are not yet fully compliant. This is what sends out the value 6. The second call sends 12 to the waiting. Yeah. So y will be 24. Yeah, we understand that. Also erases the fall off. So you see the last one is, so the 6 is gone. Yep, makes sense. Oh, it's way too many. All right, so to kind of give an idea how it works, now let's try it again. To pass the values resolved by the promise. So you'll take it out, right? But I need to check. I need to check to see if there's anything more that will be yielded out. So it will be a loop, right? And each time we will yield something out. We have a value. We have a done, okay? And they say, no, but it yields a promise. So I need to wait for the promise to resolve. And once the promise resolves, it is your function's responsibility to pass the values resolved by the promise back to the generator. So we'll call next, right? When you call next, you have to put it back in. If the promise rejects, your function should throw that error back to the So when it rejects, so basically dot catch, right? Error, then we will next to put the error back in, okay? And if the cancel callback is called, so we need to return a cancel, okay? If the cancel callback is called before the generator is done, your function should throw an error back to the generator. The error should be the string, but not an error object. If the error was caught, the return promise should resolve with the next value that was yielded or returned. Otherwise, the promise should reject with a thrown error. No more code. So we will... Wait, what? So basically we'll call next. With a cancelled string. The generator is done. The promise your function return should resolve the value. If, however, the generator throws an error, return a promise. The generator throws an error. Jesus. The generator throws an error. I still have no clue. If cancel is called, okay, what does that mean if cancel is called? Well, it would be a flag, right? When you set up a flag, so when cancel is called, the flag it changes, so we can check the flag. So when cancel is called, the loop ends. You can start kind of design this. Dude, this is so okay. So here is a kind of the general idea, right? So cancel shall equal to a function. Now we need to first say let has cancelled false, right? And the function just set this to true. Okay, and then we say while true. Okay, then we say const value done go to generator.next. Okay, and then it's not value, it's a promise. Generate a promise. Okay, because return a promise. Then what do we say? Let's say I think this one should be on the outside. Okay, so while not has cancelled and not done, right? We'll get gem promise dot then we'll get the value, we'll get the value, and if your functions from somewhere pass the values resolved by the promise back to the generator. So basically is generator.next val but we need a new thing to record this. No. I don't know, man. Maybe we can say let gem promise. Okay, let done const let val equals on next. And maybe we can do this, not val dot done gen, right? And this is gen dot value. That's the promise. Okay. Say dot value on next dot then. Okay. Resolve the value and to pass back in. but we're gonna get gen equal to this again, right? Then we can keep going, okay? So we say pass the values resolved by the promise back to the generator. If the promise rejects, dot catch, error. If it rejects, the function throw that error back to the generator. Okay. If the cancel callback is called before the generator is done, so when we get out, we shall say if has canceled and not done, right? Your function should throw an error back to the generator. Cancelled. If the error is caught, the returned promise should resolve with the next value that was yielded or returned. Otherwise, the promise should reject with the thrown error. When the generator is done, the promise is actually return gen. Promise your function should resolve the value. I don't know. Is this? Oh, I'm gonna change to return two things. Cancel function and gen. I have no clue. I just put this together. Is that correct? No idea. No freaking clue at all. Okay. Nope. I don't understand. Error, nothing, error, nothing. What? Cancelled at 100. Okay, so that's that. That's fine. Right? I think this is fine. And then we have the generator. So we call next first. So this one now already get gen is only yield promise. This is not a promise. Hold up. Let's yeah, the first one doesn't even yield a promise. Oh, it's because it's not a yield. Oh gosh, we have tons of examples to work through. All right, let's try this one first. Does this one work? Nope. What the hell? I have no idea. This is the generator, and we go generator next, so we get this promise, right? We get this promise, and then it's not done yet, and it has not canceled. The value is this promise. The then val is hello. So we call this, we put hello in. That's it. Then go back up. No, we put it in, put the hello in, and then gen call. It throws an error, but I didn't catch anything here. Oh my god. So I need to catch it here, because there's going to be an error here. So I'll catch it. You know what? Let's try the first one again. So the first one, when you call gen, okay, gen.done should be done, right? If I do console.log, you know what? I think we can run this. Can we run this? Task. Then we say set timeout, cancel, call it 100, and promise then console.log catch console.log. Okay, let's do node. What is this? Library not loaded. Alright, I'm not gonna fight this. I'm not gonna fight this. All I wanted to do is just to debug this, because I don't have any way to debug. So I was just going to say, show me what's this one. Right? If we do console.log, value done is true, right? So if this is true, then this gets out. And has cancelled no, then I'll return gen. But that is not a promise. So if gen is a promise, then we'll need to return a promise. If it's not a promise, then we need to wrap it around as a promise. How do I check if gen is a promise or not? I don't know. Okay, maybe we can do that. can say Jen is an instance of promise. If it is, return Jen. Otherwise, return new promise resolve or resolve Jen. Does that one work? Oh, my bad. Jen dot value. Okay, so the first one is down. Now let's try the second one. Okay, first one is down. Let's try second one. Don't think it's working because I didn't catch these things. Yeah. So what's happening is I mean, this is fine. And then we go inside, right? So we get hello out. We get hello out. And promise dot value dot then, right? Then we call this functions. Then we have to try, right? Because it says just throw that error back in, right? So we can try this and catch. Right, we're gonna catch. But anyway, so we push the hello in. Okay, the message become hello. Then you throw something. So that's when we call this done next. So we get that, right? And then we catch the error. Then shouldn't we do this generator dot next error? Right, we pass this in again because it throws it out. What does it get at the end? No idea. No clue. Yeah, I was thinking we're going to call next. It execute this line. Then you throw an error. So I'll catch this error. Because it says if the promise rejects, you pass it back in. But if that's not actually, okay, that's actually not right? If the promise rejects, your function should throw that error back to the generator. If the cancel copy is called before, your function should throw an error back, If the error is caught, the returned promise shall resolve with the next value that was yielded or returned. Otherwise, the promise shall reject with the thrown error. So I think this is a different case. So if we try this, I shall return a rejection. I shall return a rejection. What do? I shall say gen equal to new promise reject. Shall say resolve reject with the error, and that will break. We get out. Gen is done, but it has cancelled and has now been called. Okay, let's try this. Illegal break statement. What? Dude, you gotta be kidding me. So I cannot break on the outside. First of all, this should be gen.value equal to this. Then I can say gen.done equal to true. Then we'll go back up. This will jump out. Gen.value. Gen.value. This one work? Nope. Thing is, I didn't get anything like valuable back. Just give me any. Can we use this one? Can we use like don't throw anything, right? Don't just like go from 0 miles all the way to 100 miles per hour, way too fast. Let's do this. Let's do this one. Right? Cancel that 50. Does one work? Expected object of that. Wait, hold a second. Isn't that your test case? Yeah, I guess you have to put in one line. How about this? Alright, no clue. No clue whatsoever. Can throw an error back to a general function by calling general.throw. Ooh. catch an error. Okay, so say gen.generator throw e. I don't know. This one right? That doesn't, it's not right. Nope. Alright, I gave up. What the hell? Async and promise.race. Okay. Cancel promise. Every promise rejection has to be called. Wait, what? Cancel promise? What does this one do? Every cancel promise. Every promise rejection has to be called. Now we return a promise and return a cancel promise. Huh? That's a cancel promise. If next not done, get the next. We'll erase the 2. Whoever gets will be the next. This line I don't understand. Every promise rejection has to be called. And what is cancel then? Cancel is inside the cancel promise. And cancel promise is a promise which we set cancel to this value. So cancel become a function which whenever you call cancel, it will reject. So the promise will get rejected. Cancel promise. Yeah, that's what the cancel value is going to be. So it's bound to this function. So every time you call cancel, it will reject the cancel promise. Right? It will reject the cancel promise. And whenever the cancel promise gets rejected, you will always catch it. I don't understand. Yeah, we reject with a value, and you will catch it. So what does this mean? You catch it? So I understand this, right? You have a next value, which is you call that, and you have the cancel promise, and you raise the two. See who gets it first. Who gets resolved first? So if this got resolved, not resolved, but it got rejected first, shouldn't we wait? I don't understand. What's cancel? What's promised I'll catch? What does it do? It doesn't help at all. Like I don't understand what does this one do? It says every promise rejection has to be called. Like, did you call it? Did you resolve this already? Or like what the hell is this? Like this is this one gets resolved already? Schedules a function to be so when you call then is also schedule a function. Is that what it is? Hold on. The then method is going to take up two arguments. A callback for the fulfilled and a reject case of immediately returns an equivalent chain. Callback. And rejected case. So it's allow you to chain unfulfilled, unrejected. Schedules a callback function for the eventual completion of the promise. All right, let's go to catch. The catch method schedules a function to be called, so it's not called yet when the promise is rejected. It immediately returns an equivalent promise object, allowing the chain calls to the other. It is a shortcut for .then. So you are just scheduling it. But you're already calling it, right? If you get a new promise and then you schedule this, then you're already calling it. That's something I don't understand. Like, how does one work? You're already calling it. And you're not returning anything. I don't know, man. I don't know. Like, didn't you already schedule this? This shall be rejected immediately. But the rejection is not called. The rejection is not called because you did not reject here. But look at this. This one you reject. Right? So if we say cancel equal to reject, no, it's just a function, and in this function I call reject. Right? Then we do this. It should not give me anything, right? But if I call cancel, then it should give me something. Oh, look at that. Look at that. So the cancel promise is a promise, right? But in this promise, we did not reject anything. We are saving the rejection for some later time. So we don't reject. But we schedule a function to call when it is getting rejected. And then we start the race. Right? So whoever gets up first will get the value out. But what is this value then? Dot catch. So the returned value, the resolved value. So if I say promise1 dot catch, okay, we catch everything, then run. Or can we just go then? But there's no then. A lot of race. With the adventures of first promises to settle. And rejects if the first promise to settle is rejected. The return promise remains pending forever if the iterable past is empty. It's non-empty. Okay, so sleep, I have resolve, reject, set timeout, time. If fulfilled, we do this. Reject, we get error, okay? Two, Okay, so we have a sleep. This gets fulfilled. 3. Error not called. So this we'll call error because this got rejected. So this one we call okay, because this will not get resolved. It will not get resolved because the resolve was never called. So this will forever hang. Is that right? Is that right? So if I don't do anything here, yeah, if I don't call resolve, or if I don't call reject, this promise will never get resolved or rejected. So that's this, right? It never gets resolved because there's no resolve. So every time it's always the next dot value gets resolved or rejected first. So what if this one gets rejected? If this gets rejected, that throws an error. So when you call this, that we call try. So this becomes an error. And now we throw the error back in. That's good, I understand that. If this throws, shouldn't you do this one as well? I don't understand this one. Okay, so this is saying we'll return a promise. I return a cancel function, okay? And this promise is an async inside. No. This promise is a return value of this async function. And this async function, we get the next, we say if it's not done, then we'll erase this 2. If this one gets out, we push it in. This one gets it rejected, we'll throw. This gets rejected, we'll throw as well. Does this one make any difference? Wait, hold a second. If I cancel 71 seconds. It doesn't make any difference. If I need to understand it, I don't think this one shall be involved. If my understanding is correct. Right? If my understanding is correct, we have a cancel. So whenever we call cancel, we will reject this promise. If we don't call cancel, this promise will never be resolved or rejected. So every time when you inside this, right, this promise, and we try to call this promise, it will need to execute this code. So every time what happens is we'll always evaluate this one first. If it's good, we push it back in. If it's bad, we do this. And then once this is done, right? Once this is done, but how do we know it's going to be done if the cancelled, if the error is caught, the return promise shall resolve with the next value that was yielded or returned. Otherwise, promise shall reject with a thrown error. No more should be executed. Then how do you prevent, you call a cancel, right? And we'll reject with this. And this goes in to the generator. So if error is caught, the returned promise shall resolve with the next value that was yielded or returned. Otherwise, if you do throw, then if it's not caught, the promise, otherwise the promise should reject. So if this one throws an error, makes sense, right? So if we cancel is called, and I'll throw this, now we push this into the generator. So if it's caught, the return promise shall resolve with the next value. So we just keep going on, right? We just keep going on. That's what I think. You keep going on. It's only when it's not. Okay, let's see. Is this one correct? Yeah, it is correct. No puedo. No puedo at all. Alright. Not able to do do anything about this. Completely clueless and have to rely on the discussion. So this is adapted from the most voted. The use of promise.raise is brilliant, but the setup of cancel promise is genius. Note that the cancel promise does not resolve at all, nor does it reject immediately. Instead, the power to reject cancel promise is given to the cancel function. In other words, the cancel promise is a never resolved promise that can only be rejected immediately once the cancel function is called. Now when we raise next.value and cancel promise, as long as the cancel function is not called, next.value will always be the first to resolve or reject. If resolved, the resolved value gets passed back to the generator. Otherwise, the error gets thrown back to the generator as well. Now, another piece of ingenuity is when cancel is called. The cancel promise is rejected and most likely wins the race. The rejection gets caught in the function, and then the cancelled string is thrown back to the generator. Now, if generator.throw works, does not throw another error, that is, the cancelled string gets caught in the generator code base, we continue, right? We continue the generation. However, if an error is thrown because of the cancelled string, generator.throw will throw the new error, which means the promise, right? The returned promise will reject by whatever that error, that new error will be. Yeah, I am not able to write this, but I can sort of understand what the codes are doing. Okay, I think we need to visit this again tomorrow. Read a few more and then kind of just get a feeling of it. This is like really tough JavaScript. It's good. It's good. All right, that'll be it for today, and I'll see you guys tomorrow. Good luck to me. Adios.